Okay, November 2023, paper 1, variant 2. Okay, question 1. A student investigates the oscillation of a mass suspended from a spring. Student pulls the mass down from its rest point, okay, rest position P, and then releases it so that it oscillates vertically. So it keeps on moving up and down. The student then follows instructions listed to find the period of the oscillating mass. Count 10 oscillations, divide the time on the stopwatch by 10, start the stopwatch, and as the mass passes upwards through point P, stop the stopwatch. What is the correct order of these instructions? How can I put these instructions in the correct order? If we think about them carefully, we'd find them, yes, you have to start off with 3, and then, okay, you have to start off with 3, and then 1, and then 4, and then, yes, 2, which is B. Okay. A student measures the average speed of a cyclist in a race. Which quantities must be measured? Which quantities must she measure? The total time taken. She needs to find the average speed, right? Average speed equals total distance over total time. What is the total distance and what is the total time? So the total time taken to complete the race, right? And the total distance traveled by the cyclist. Distance and time. She accelerates steadily from 8 to 4. Okay. How far does she travel in the last 3 seconds of her acceleration? From rest to 8 meters in 4. So she accelerates, okay, in the first 4 seconds. The question is, how far does she travel in the last 3 seconds of her acceleration, not of her total acceleration, in the last 3 seconds of her acceleration. So basically, we need to find the area under the graph. Yes, not of the whole triangle. No, of this part of the triangle in the last 3 seconds in this part of the triangle. Can I find the area? Yes, I can find the area. This is a trapezium. Trapezium is a bit difficult. What can I do? Can I find the total triangle and then just subtract this smaller triangle? Can I find the total triangle and then subtract the small? Yes, I can do that. So basically, it's half times base times height minus half times base, right? Times height. Half times base times height. The initial half times base times height is the larger one is half times 4 times 8, right? And the smaller one is half times 1 times 2, right? Half times 4 times 8 and half times 1 times 2. What is half times base times half times 4 times 8? Half times 4 times 8 is 2 times 8 is 16, right? So this is 16, and half times 1 times 2 is 1. 16 minus 1 is 15, B, right? So this is the area traveled in the red section, which is the last 3 seconds of her acceleration. Person steps onto a bathroom scale. The bathroom scale records the mass and weight. Which row shows the readings on the bathroom scale? Readings on the bathroom scale. A mass, can it be in newtons? No, cannot be in newtons. If the mass is 60 kilograms, would the weight be 590? 60 times 9.8. Yes, it's very close to 590. So it is B. Which equation is correct? Density equals mass times volume. No. Weight times volume. Mass equals density times volume. Well, density equals mass over volume. So mass is density times volume. Yes, it is correct. Which object is in equilibrium? The only object is in equilibrium is what? Is D. 20 newtons and 10 and 10, which is 20. A would be wrong. Why would A be wrong? Because it would rotate in this direction. It would rotate in this direction, so A is wrong. The pivot exerts an upward force F on the ruler. What F is equal to? What is F equal to? What is F equal to? So basically, we need to use the moment, or when I say in equilibrium, we have forces are equal. The upward forces are equal to the downward force. Resultant forces is equal to 0. So the downward forces are what? 2 newtons and 2 newtons. The only upward force is 4 newtons. Okay? The only upward force is the 4 newtons, right? But should I include the weight of the ruler or not? Should you include the weight of the ruler or not? Yes, you should include the weight of the ruler. Why? Because there's a weight of the ruler which is somewhere, it's acting somewhere here. For example, let's say that the weight of the ruler is 5 newtons. Okay, so the total downward force is 4 plus 5, so the total upward force should be 4 plus 5. You have to include the weight of the ruler, the downward force, which is the weight of the ruler. Okay, even though it does not cause a moment, yes, it doesn't cause a moment, but it still is included in the force equation. We have a car which is moving from X to Y. The energy in kinetic store as it's moving from X to Y. What's happening to the kinetic energy? What's happening to the gravitational potential energy as it's moving from X to Y? Kinetic energy is increasing because it's moving downwards. What's happening to the gravitational potential energy? Is decreasing because they're moving downwards. In a small power station, biofuel is used to generate electricity. Which energy stored is reduced by this process? Biofuel. It stores what type of energy? Biofuel stores chemical energy. So as you burn the biofuel, the chemical energy decreases, right? The chemical energy decreases. An electric car is charged overnight in 8 hours. 180 megajoules of energy is transferred. What is the power of the charger? The power of the charger would be what? Power equals power equals energy times time, right? Power equals energy times time. What is capital M? This is a new unit. Capital M is megajoules. Megajoules means times 10 to the power of 6. Megajoules means times 10 to the power of 6. In 8 hours, okay, in 8 hours, should I convert the hours to seconds? Yes, I should convert the hours to seconds. So you multiply by 60 and you multiply by 60 again. 180 megajoules, okay, 180 megajoules times, I'm sorry, power equals energy over time. I do not know why I wrote energy times time. Definitely it is over time. Yes, 180 megajoules divided by 8 times 60 times 60. 180 mega means that times 10 to the power of a times 10 to the power of 6. So let's use the calculator to find the power. If I use my calculator to find the power, it is 180 times 10 to the power of 6 divided by 8 times 60. Okay, 8 times 60 times 60, which is 6,250 watts. 6,250 watts. Can this be written down as 6.3 kilowatts? Yes, it can be written down as 6.3 kilowatts. Okay. Tractors have large tires. This helps prevent the wheels from sinking into soft ground. Which statement explains this? Which statement explains this? Why? Because the larger tires exert a greater force, exert a greater pressure, or a smaller pressure. Yes, a smaller pressure. They exert a smaller pressure. Brownian motion is the random motion of particles. In which states of matter is Brownian motion observed? Brownian motion is usually observed in liquids and gases. Yes, liquids and gases. Question 13. A student investigates the relationship between the pressure of the gas and its volume at constant temperature. At what? At constant temperature. So how does the pressure behave with the volume? As the volume decreases, what's happening to the pressure? Is the volume decreasing constantly? No, it's not decreasing constantly. But you can take a look at, for example, when it was 24, pressure was 10. When the volume increased to 32, the pressure decreased, right? When the volume increased even more, the pressure decreased even more. What is the correct conclusion from this experiment? What is the correct conclusion from this experiment? The volume decreases when the pressure increases, or vice versa. When the volume increases, the pressure decreases. They are inversely proportional, which is something we already know, right? Hmm. A wooden wheel can be strengthened by putting a tight circle of iron around it. Which action would make it easier to fit the circle over the wood? How can I fit the circle over the wood? Hmm. How can you do that? By cooling the iron circle, by heating the wood, but not heating the cooling iron. What should you do? Hmm. We need to increase the diameter, kind of increase the volume of this iron circle so that it could fit around the wooden wheel, right? You need to increase the volume, increase the diameter of this iron circle so that it could fit around around the wooden wheel. So how could you increase the volume? How could you increase the volume of this iron circle? By heating the iron circle due to thermal expansion, right? Thermal expansion, the volume would increase, so it could fit around it. And then when it cools down, it would shrink, so it would fit tightly around the wooden wheel. Question 15. Which diagram shows the processes happening during changing of state? Changing of state. From gas to liquid boiling, gas to liquid condensation, liquid to solid boiling, melting, huh? Solid to liquid melting, liquid to gas boiling, right? Solid to liquid solidification, no. So it is C, right? Question 16. Which diagram and reason explain the heating of the room by convection? The heating of the room by convection. Diagram X or diagram Y. Isn't this a radiator, a heating radiator? Temperature increases, the temperature of the air increases. So the hot air, how does the hot air move? It moves upwards, right? And then it moves this way and goes back to the radiator, right? So diagram Y is wrong. It's X. Air density decreases when it is heated, or does it increase? Yes, it decreases. That's why the hot air moves upwards. Which description and example are correct for a transverse wave? Which description and example are correct for a transverse wave? Is a sound wave a transverse wave? Is a sound? No, it's not transverse. Direction. The transverse wave. Does it move up and down? Does it move perpendicularly, or does it move left and right? Parallel. Uh, is it parallel or is it perpendicular? No, it's not parallel. It is perpendicular. So yes, waves on a rope. If you have a rope and you keep on moving it up and down, then you are creating a transverse wave. Yes, that is correct. Question 18. What is the name of this effect when the waves spread? This effect is called the diffraction. Yes, diffraction. Red, green, and violet lights are part of the visible light spectrum. What is the order of colors from shortest to longest wavelength? Shortest to longest wavelength. So we know Roy Gibev, right? Roy Gibev. It's in this order from the longest wavelength to the shortest wavelength, right? You have the longest wavelength, and as you move downwards, you have the shortest wavelength. So we want to put them in the correct order, from shortest order to the longest wavelength. Red is the longest wavelength, so red has to be here, which is D, right? Violet is the shortest wavelength. Yes, so it is D. Okay. Which diagram shows the image correctly formed by reflection? Reflection, if you have object A, if you have an object on the left hand side, how will the image appear on the right hand side? It will be laterally inverted. It will be laterally inverted. So it would be D. Lateral lateral inversion. Okay? Left to right. Okay. B and B and C are wrong. Why are B and C wrong? Because the image isn't inverted up and down. It's not vertical inversion. This is not a vertical inversion. It's only a lateral inversion. Which lens has the longest focal length? Focal length. Do I care about X? Should I even look at X? No, I don't care about X at all. I only need to look at Y. So which of these has the longest wavelength? Longest Y, basically, right? Longest length in Y. 2, 3.1, 2.3. It's 3.1. So it's B, right? The table shows different types of waves in the electromagnetic spectrum. Where do all of the waves travel at the same speed? Hmm. Where do they travel at the same speed? Hmm. In a vacuum. In a vacuum. Which statement about sound that can be heard by a person with a normal hearing is correct? Person with a normal hearing. Normal hearing. The sound is longitudinal or is it transverse? Again, are sound waves transverse? No, they are not. Hmm. So it is a longitudinal wave with a frequency between 2 hertz and 20 hertz. 20 and 20,000. Yes, 20 and 20,000. 20 and 20,000. Yep. A hard magnetic material can be used to make a permanent magnet. Soft magnetic material can be used to make a temporary magnet. The iron, should it be soft? Yes, it should be soft. And the steel should be hard. Yes, we call it soft iron and hard steel. Hard steel is a permanent magnet. Yes, and soft iron could be a temporary magnet. A battery is connected to an ammeter and a resistor. The ammeter reading is 0.2 amperes. What is the ammeter reading? An electrical insulator is connected in parallel with the resistor. Electrical insulator is connected in parallel with the resistor. Would this actually affect the current? If you have an insulator in parallel, does it do anything? No. If he said actually an electrical conductor, it could have caused a significant difference, yes. But since this is an insulator, so no current will pass through it, so it's as if it's not there. The current will remain the same. The current will remain the same. Which unit is used to measure the electromotive force, EMF? Yes, EMF is in volts. Which equation is used to find the resistance? R equals V over I. Yes, R equals V over I. Diagram. Rod R is suspended from an insulating thread. When the positively charged rod Q is brought close, it moves away. Which conclusion can be made from this observation? Q and R. R has to be positively charged. Yes, must be positively charged because they repel. Because like charges repel. In which heating system circuit would the thermistors not be useful? Thermistors, in which of these systems would the thermistor not be useful? Thermistor, yeah, we can use it in a lot of applications, right? We can use it in a lot of applications. To keep different rooms at different temperatures. Yes, because it would measure the temperature of the room and it would for example, if the temperature increases or decreases, it could cause something in a certain, so this is useful. To turn an alarm on or off if it overheats, if the system overheats, yes, we do need a thermistor in this application. To turn a heating system off yet at a particular temperature, yes, we can use it. To turn on a heating system when a sound is detected, you have a heating system, so yes, you can use a thermistor. No, you won't use the thermistor. Why? Because the thermistor wouldn't be effective. The thermistor cannot detect the sound. It cannot detect the sound. So this is the wrong application. Okay. Which statement is correct? A fuse is included in a circuit to prevent the current from becoming too high. Sounds right, doesn't it? Yes, and it is right. Fuse does prevent the current from becoming too high. Fuse melts when the current increases above a certain value. Which graph shows an alternating current? Which graph shows an alternating current? Is it A? Can it be A? No, it cannot be A. Why can it be A? Why can't it be A? Because it's still all of it is positive. B is direct current. C is also positive. It has not crossed into the negative section. It is only D. Okay, positive and negative. This is what we call an alternating current. Now, we have a wire in a magnetic field. There's a current in the wire. And this is the current that is passing through the wire now. This is an alternating current, isn't it? Yes, it is an alternating current. Current keeps on increasing and decreasing, increasing and decreasing, right? What happens to the force on the wire? If you think about it, you have current passing through a wire, but the current is not constant. It's an alternating current. It keeps on increasing and decreasing. So what happens to a force on this wire? Yes. What happens to a force on the wire? The force, is it constant? Is the force constant? No. The force keeps on alternating with the current. So the force keeps on increasing and decreasing in one direction and then in the other direction. So the force on the wire alternates between one direction and the opposite direction. For example, the wire would keep on moving into and out of the page. Into and out of the page. صح. Yes, it is A. What is the relationship between these quantities NP and SVP and VS? Is it A? No. Is it D? Nope. Is it B or is it C? VP over VS equals NP over NS? VP over VS equals NS? No. So VP over VS equals NP over NS. Yes, it is D. Which diagram shows a negatively charged ion? Which diagram shows a negatively charged ion? Negative. So we need electrons, the number of electrons to be greater than the number of protons. Protons and electrons. So we have 2 and 2. This is not negative. 2 and 2. 2 and 2. One proton and 2 electrons. So it's D. Which row describes an example of radioactive decay? Radioactive decay. Can radioactive decay happen from a stable nucleus? No, it has to be from an unstable nucleus. If it emits an alpha particle, does the element change? Yes, it does change. So the element has to change. The element has to change. What about a beta particle? The element also has to change. Actually, the element has to change. So if an alpha particle is produced, the element changes. If a beta particle is produced, the element also changes. It has to be an unstable atom at first. An unstable isotope. What is the half-life of this source? What is the half-life of the source? It started off with what? 250. So 250 divided by 2 is 125. Where's 125? 125 is somewhere in between, right? Almost 4. It's greater than 3 but less than 4. So it's between 3 and 4. It's between 3 and 4. 37. What is the most effective precaution to reduce the risk when handling, storing, or using a radioactive source that emits gamma rays? Emits what? Gamma rays. Handling the source for the least possible time. Okay. Have a fire extinguisher. Why would this help? Why would this even be possible? Store the source at a low temperature. Temperature does not affect the radiation. Wear plastic safety goggles. Why would safety goggles even help? Not at all. Hmm. It's only A. Least possible time. Approximately how long does the moon take to orbit the Earth? Yes, it takes 1 month or 28 days. The sun transfers energy to the Earth through the electromagnetic radiation. What are two of the parts of the electromagnetic spectrum which most of the energy belongs to? Most of the energy belongs to what? Infrared and visible light. Infrared and visible light. Yes, and then ultraviolet. But you do not have the ultraviolet in this question. What provides evidence that the universe is expanding? Yes, the universe expands because of what? Of the red shift, which is light from the distant galaxies is shifted to longer wavelengths. Red shift. Okay?